In this video, I would like to look at creating a channel that flows into a drainage catch basin in a ditch and then flows to through a system to the pond. So I've already kind of designed a system here, just a very simple example here, where I've got some catch basins that take the water from the ditch and route it through a pipe system over to a pond. And I've already kind of, analyzed that system, so we could take a look at the profile here. And just real quick, you can see, this is the current state of the profile. So really, I just want to show how you might model a channel or a ditch on, a simple channel here that feeds to that catch basin. So first thing I want to do is I'm going to place a node at the upstream end of my channel. And in our examples workspace, you can see we've got, under stormwater nodes, we've got cross-section nodes. And so this particular channel, it's a 2-foot bottom channel with 4-to-1 side slopes. So we've got a node set up for that. But most importantly, we got to connect the channel to a node. So go ahead and select that. Just give it cross section number 1. And I'll move up into, well, first I'll select my reference surface. And let's zoom on into where I want to place it. So I'm just going to place it, in the middle of the ditch here. And just have a 0 rotation there. And if I zoom in here in the 3D, you can see it's basically just a point. So that represents the invert of my channel. Now my downstream node is the catch basin. So I've already got the downstream node there. So in a channel, and if we take a look at the properties of this node, so I'll just select it and look at its utility properties. It's very simple. It's got a cross-section set. It's pulling from a catalog, and it's got its dimensions. So we'll close that. And I'm going to go ahead and place a conduit. And I'm going to select the conduit under stormwater. We've got a section of channels. And so it's, in this case, I could do channel grass, or I could do channel from node, and that would read that cross-section element for its cross-section information, and I could go from cross-section node to cross-section node as I go down through my channel. But I'm just going to create this channel grass here, simple. So I'm going to start there, and I'm going to connect it up to the catch basin. Now, one thing I'll notice, and I wanted to point it out in this video, and is you can see that when I connected it to the downstream, it connected to the invert, and then of course it ran its slope back. So I can see my channel is actually underground again now. And part of the reason for that is if I look at the channel itself and look at its utility properties, we have on our prototype set our set invert to start and set invert to stop to true. So it's going to it's basically going to read the node that as I snap to it. So that node downstream had a bottom already set at 162.41. And then it ran its a nominal slope back up, if you will. So really what I want to do is, maybe in my prototype, I could have those set to false. And so that, therefore, and also I'll point out, if I look at the properties here, I can't change those. They're all grayed out. So in order to change those, this is a little bit of a change in behavior in this version from previous versions, but I would change that to false on both in my case, I want to do both the upstream and downstream. And if I go back to the properties here, you can see, okay, now I can actually edit those properties there, or I can edit them here. Now here, I want to connect at 166.18. That's the top of my structure there. So, 166.18. So my downstream invert or stop invert is at 166. Let me zoom over so you can see it when I do it. 166.18. So you can see it pushes it back up to where it belongs. And then of course the other end here, if you can see this one, the ground at that point was 166.958. So the downstream is 166.958. So I'll close that, and then you can kind of see how it just lays itself on the surface there. So, just wanted to point that out is, in conduits, if your prototype's set to true, then it it locks the invert to the node so that as you adjust the node, the pipe goes with it, um, up and down, or in this case, the channel. Now finally, if I go ahead and just really quick take a profile, so let's profile through here. I'll just do a hydraulic run to outfall. If you remember the profile earlier, and we'll select a miscellaneous utility there. And if you see here from the cross section to the end wall, so you can see my channel going down, running into my catch basin in the ditch, and then flowing down. Now, right now I have my catchments draining to the catch basin, but I'll go ahead and switch those so that we can just compute the flows. So I'm just going to look at this particular catchment here, and right now it's draining to the catch basin. So I'll just, I'm going to say let's drain here to the upstream, and then this catchment is also draining to the catch basin, and I will now drain that to the cross section, CS1. So when I compute the flows, and close that, and I'll close that for now, and let's take back a look at the profile. And so there's my profile with my water in my ditch draining into the catch basin and on down. And of course you can look at the hydraulic properties of your channel, and you can look at the computations, and the various results there. I also will note that when you connect up a channel to a node, like for example in this case I connected to the ditch node, one of the things you have to be aware of is um, it will ask you to make sure that you have a gutter shape, so it needs to know what's going on upstream of this catch basin, and so matching that. So I made sure that I matched a trapezoidal gutter, 2-foot bottom width, and 4-to-1 side slopes. It's rounded up because my decimal place is only 1 decimal, but it's 0.25 there. Um, so that's one thing, is you make sure that your gutter shape matches what your incoming ditch is so that it computes correctly. So that's just an example there of creating a simple channel and draining it to a catch basin out through a piping system.